All right. This exercise, which is not problem 2, but which is exercise 14 in this section, I've done this one as well, so let's go through it. If you have a group G with proper subgroups H1 and H2, and you assume, for contradiction, that G is its union, then since these are both proper subgroups, then there's got to be one element that's in H1 but not in H2. We'll call that G, and then you have some element H that's in H2 but not in H1. And so basically you look at the element GH and you prove that it can't be anywhere. So it's got to be in H1 or H2 because G is a group, and so you're multiplying two elements in G together, and so it's got to stay in the group. So it's either in H1 or H2. If it's in H1, then since G is in H1, G inverse is in H1, and so you can multiply inverses in a subgroup as well. So G inverse times GH is in H1, but the G inverse and the G cancel, and so H is in H1. But that contradicts how we chose H, because we chose H to not be in H1. And therefore, since this is a contradiction, it cannot be the case that GH is in H1. So that's that we've proven that. Conversely, then it has to be that GH is in H2, but then you basically do the same argument, but for H, and you multiply GH on the right by H inverse, and you conclude that G is in H2, but that contradicts the fact that you chose G to not be in H2. And so basically GH, it can't go anywhere, and so everything breaks, and you get a contradiction, and hence it cannot be the case that G is H1 union H2, where these are two proper subgroups. And this completes the proof.